right, so we are continuing with the integration using u-Substitution. Here we go. And oops, I had it and I messed it up. We were here, correct? Okie dokie. So, remember that there's no product rule. Take a deep breath over there. There's no product rule for integration. So if I was going to take the derivative of this, yes, I'd have a product rule, can do that. Does not work that way for integration. You okay over there? All right. All right, so if this was just plain old e to the x, if I integrate e to the x, what do I get? E to the x. Okay, but this isn't e to the x. This is e2, and then instead of x, there's a whole other function there. So that is kind of like our inside there, what we will take as our u. So u is equal to 3x plus 1. Yes. Okay. Then what do I do with that? Take the derivative. So du equals what? 3dx. Okay. Now, this will be taken care of with our u stuff. Here's the dx, but what am I missing on the right-hand side? 3. So I'm going to multiply by 3. What goes on the left-hand side? 1/3. Okay. So then I rewrite this as 1/3 times the integral. Instead of e to the 3x plus 1, it is e to the u power. And then my du, this 3dx is all together right there. That's du. Okay. All right, so then now I can integrate, right? It's something that's I can handle. So this is going to be 1/3 times what? E to the, when you integrate e to the u, what do you get? E to the u. Right? Because the derivative of e to the x is e to the x. So when you go the other way, it's still just e to the x. Remember, e means easy. Okay? So that's it, and then we can't forget our plus c. And then we substitute back in 1/3 times 3x plus 1. No, that's not right. Yeah, thank you. E to the 3x plus 1 power plus c. Everybody okay with that? Any questions about that? Okie dokie. All right. Let's look at this next one. E to the 1/2 x. All right. So what do we think we can use for u here? Not sure what to do with that. No, I don't know, right? What is that? That's e to the 1/2, e to the 1 over x power over x squared dx. Yes? Yeah, let's try that one. So let's go with not du, oh my gosh. U is equal to e to the 1/2 x. Oh my God, what is wrong with me? It's 1 over x. It's not 1/2 x. I don't know why I keep saying that. 1 over x. It's because I was trying to find it over here. Let me find it over here. There we go. Okay. So if I do that, what is that going to help me any there? Because if I take the derivative of that, that's going to be nutso. Would you agree? Sure, maybe. So let's take the derivative. Let's see what happens. Du equals, all right, so what's the derivative of e to the 1/2 x power? Oh my God, not 1/2 x, 1 over x. I don't know what is wrong with me. E to the 1 over x, if I say it again, you'll know what I mean. But then what do I have to multiply it by? The derivative of, this is equal to e to the x to the -1 power. So I get -1 times x to the -2 power dx. Is that right? Now that I'm confused, yeah. Because that's not how I did it over here, but you said let's try this one, so we're going to try this one. We're going to see what happens. I'm curious as to whether or not we get the actual answer. I think we will. Okay, so look at what we have here. We good on that? Now that I'm not an idiot and I can take a derivative, my brain was on integrals. All right, so now I need to figure out what I'm going to do with u. And this is just, how can I rewrite that? Can I rewrite that somehow? Is it going to look like this? If I rewrite this, I'm going to get e to the 1 over x, not 1 over 1/2 x, over, and that's a negative out front, x squared. Do you agree with that? What does that look like? It's what we have over there, right? Is that what we have? Yes, it is totally what we have. And I think that was what was throwing me off because, again, not how I worked it, but again, it's working out, so we're fine. So now I'm going to ignore this middle part because, well, first of all, here, du equals this, right? And I need this to match something in there. Well, it's the same, but what's different? It's negative. So really what I have here then is that negative du is equal to negative, no, not negative anymore, e to the 1 over x squared dx. Does that work out for you? Okay, so now when I go to substitute things in, I don't even have a place to put an actual u. Would you agree with that? Yes? Okay. So this negative du, isn't that really just like negative 1 du? I think that might help things out a little bit. Yes? Negative 1 times du is just negative du. Because I replaced this entire thing is du. There's no place to put a u. I just have negative 1 du. Okay? If you integrate a constant, what do you get? What would I take the derivative of to just get negative 1? Yeah, right? So if I take, let's think derivatives, right? When you're trying to do the integrals, think the other way. If I give you negative x and you took the derivative, what would you get? Negative 1, right? So if I have negative 1 and I'm going the other way, and this is in terms of u, this is going to equal negative u plus c. Do you see how that works? We'll do it a second way too. Are y'all going to have room to write a second way too, just so you can see the difference? Okay. All right, so negative u plus c. Now when I substitute that back in, that's going to give me negative e to the 1 over x plus c. The other way is what I would say it's a little less complicated, but if you don't notice it, like you can't just go, oh, I would choose the easier way if you don't even know what to choose. You know what I mean? Like this was the first thing I heard, so I thought we're going to try it. And then it worked. If it didn't work, we would have turned around and gone down a different road. I didn't know if this was going to work because it's not how I worked it, but it works. I said work a lot of times. Okay. So let's redo this a second time. Let me rewrite it down here just so I have more room. You don't have to rewrite the original part. It was the integral of e to the 1 over x squared dx. Okay. So what I chose for my u was 1 over x. Okay? So I'm going to choose 1 over x. I'm going to say that u is equal to just 1 over x, not e to the 1 over x, which, again, nothing wrong with it, but that's what I chose, right? I'm going to rewrite this so I don't mess this up royally again. Oh, my God. X to the negative 1 power. It's a very easy derivative that apparently I didn't know how to do it earlier. So the du is equal to negative x to the negative 2 power dx, right? Which is the same thing as negative 1 over x squared dx. Then we're kind of doing the same thing we did on the other one, but we don't have all that e nonsense in there. And so then here, I'm going to say that negative du equals 1 over x squared dx. Everybody with me at this point? So now that I'm here, when I go back over here to put it in, instead of e to the 1 over x, it's going to be the integral of e to the u, and then the 1 over x squared dx is right here. And so there's my negative du. Negative du. But I can just pull the negative out front. That's what I'm going to do. Du, I can just put the negative out there. Do you see how it's the same but not as wonky looking because of the e? Because then we're going to do the same thing. When you integrate e to the u, what do you get? E to the u. So negative e to the u plus c. So that gives me negative e to the 1 over x plus c. It is way easier. So my suggestion to you, because again, maybe you try that and it doesn't work and you have to go with the e. But maybe try not to get something as involved in that, even though it totally worked. Okay, just know this also shows you, so I'm glad that we did it this way, that there's sometimes more than one way to go about it. But again, you're not always going to know what the easiest way is, unfortunately. Okay, what questions you got? We good? Okay. And I wouldn't say that there's this 2 or 3 ways on absolutely everything, but there's definitely other options. Okay, so let's look at this one. All right, what would you pick for u? (2x minus 1). Okay, so we're going to say u equals 2x minus 1. So du equals 2 dx. Does that look like it should work? Yes. But I need to add a 2 over here, or not add, but multiply. So a 1/2 goes out here. So I'll have 1/2 times the integral of 1 over u. And then this is matches my du. So now, when I integrate u to the negative 1 power, or 1 over u, which is what I was doing on the other one, what do I get? You were right. This natural log? Absolutely. You're right. So it's 1/2 times the natural log of the absolute value of u plus c. So then that gives me 1/2 times the natural log of the absolute value of 2x minus 1 plus c. All right, we good? Questions? All right, you do the next one. Ooh. How are we doing? We're just stuck on this. Let me see. Have you done any of it? Okay. Okay. So since you have not done anything wrong, right? But if I'm going to replace with this u, this has to be stuck with this to give me my du, and there's not an easy way for me to make this into this. So then when that happens, change what you don't have to erase it, just mark it out and try that as u, and then see if you can do it. Try the denominator, do the denominator instead of the numerator. Because if I take the derivative of this, see how that'd be 3x squared plus 1? And that's what we have up there. Okay? So, but it's fine that you tried something, doesn't work, you try the other one. That's going to happen. So, good job. so since you, okay, good. So you did this, and, oh wait, what is this? X cubed. Yeah, but this is 3x plus what? Plus 1, yeah. So you tried this one, it didn't work, right? That's fine. So then we try this one. If that's your u, then u goes down here. Yeah, and then all of this goes, you forgot your dx down here too. There you go. And so then all of that gets replaced with du. Yes? Yeah, let me see what the final answer is. Off the top of my head, I was going to work it, but natural log of, that looks good. Very good. All right, so I saw this, u equals, okay, so let me ask you this. At this point, have I done anything incorrectly? No. But when I do that, like, because I thought, I'm going to try that for you. I got 6x dx, and I'm like, well, if this is going to be u, then that doesn't help me down here. So instead of trying to force it, I'm going to try something else is u, x cubed plus x. So then du gives me 3x squared plus 1, and that I think I can work with, right? So not only that, I don't have to multiply anything this time. This is what I have over there for du. So I'm going to integrate 1 over u du. Yes? And when I do that, I get what? Natural log, absolute value of u plus c. So that is the natural log of the absolute value of x cubed plus x plus c. And my suggestion to you, if you do the wrong one, this wasn't wrong. If I pick something that didn't work, you don't have to worry about erasing it, but I would at least mark it out so you don't accidentally use that u or something as you go along. Okay? So even on the AP exam, don't spend time erasing and doing all, just mark something out and move on. Okay? We good on that? All right. So we are going to change this next one. We're going to change it to something completely different. So this is going to be the integral of x times the square root of x plus 3. Okay? And dx. All right. We okay with that? All right. So now, what do you want to pick for u? X plus 3. U equals x plus 3. I agree with that. So then I get du is equal to 1 dx, right? Okay. So that's kind of a problem. Would you agree? Because if that was, because I have this x here, like the u will take care of this. The u doesn't directly take care of this. And if this was a 3, then I could do a 3 and a 1/3, you know, I could do something like that. If it's a variable, I cannot do that. But it does not mean that I am stuck. I can go back up here, and since u equals x plus 3, if I subtract 3 from both sides, then u minus 3 equals x. Would you agree with that? Oh, great. More math. Okay, so because I could have thought, well, maybe I chose the wrong u. Well, then if I choose x, that's not going to work either. The same thing's going to happen. So now when I substitute in things, because I remember I have to get rid of all of my x's. I don't get to leave any in there. Instead of x, I have u minus 3 times the square root of what? U du. Everybody with me? All right, now, we don't have a product rule, right? There is no product rule for integration, but that's okay because I can fix the fact that it's a product because I can distribute. Yes? The square root of u is the same as u to what power? 1/2. When you multiply things with the same bases, what do you do with the exponents? You add them. So if I'm going to multiply u times u to the 1/2, that's going to give me u to the what? 3/2. Yeah. 3/2 minus 3 times u to the 1/2 power du. Okay, so that's kind of a special case. Now, you finish that up. you're going backwards. Okay, I heard a whole lot of what the heck, and I hear erasing. So tell me where we went wrong. Just be honest with me. Everyone, everywhere. You just forgot to take the integral. That could be a problem, right? Oh goodness, we were all erasing. So let me erase this and let's go back and let me talk you through it. No, I'm going to put it back up there. I'm going to put it back up there. All right. So let's talk about the process. It's the reverse of the power rule for derivatives, right? So that means instead of subtracting 1 from the exponent, I add 1. 3 halves plus 1 is 5 halves. Then you have to divide by the new exponent, which is the same as multiplying by 2/5. Then I have minus 3 times, when I add 1 to the 1/2, that gives me 3 halves, so that's u to the 3 halves power, and then I have to multiply by the reciprocal, and then I have a plus c. Everybody okay with that now? Yes. All right, so now when I'll clean that second one up when I do, let's see, my u was x plus 3, so this will be 2/5 times x plus 3 to the 5 halves power minus, then these 3's cancel out, right? So I just get 2 times u to the, oh, not u anymore, good lord, times x plus 3 to the 3 halves power plus c. Now I'm going to challenge you, because if this was a multiple choice question, this could be your answer choice, or it could be a factored form of this. See if you can factor out x plus 3 to the 3 halves power. See if you can factor out x plus 3 to the, factor out the GCF, or either way. See if you can factor that out. The x plus 3 to the 3 halves. See if you can factor that part out. Okay, let's think about factoring in general. If I have 2x plus 6, because this is how you learned how to factor out the GCF. They taught you that you're going to then, I'm going to erase this in a minute. I know my GCF is 2. That's what I want to factor out. So I literally divide both terms by 2, right? The 2 comes out front, and that gives me x plus 3, right? So anytime you're factoring, just think about dividing it out. See if that helps, and see if you can. We're going to pretend like, and here's the cool thing about the plus c. You can kind of pretend like it's not there, but because it absorbs everything. And really, I just want to see if you can figure out what's going on here. So let's talk about this. In this first term here, are there going to be some x plus 3's left? Yes. So I'm still going to have an x plus 3. Now, if I divide out the 3 halves, right, that means I'm going to subtract the exponents. So what's 5 halves minus 3 halves? 2 halves, which is 1. So I don't even need an exponent there, right? Minus 2. And then this whole thing came out, right? And then a plus c. I'm not saying you have to, but that, again, that could be a multiple choice answer. But let's look at it this way. If you get this and you're pretty confident you're right, and this is an answer choice, could you at least go the other way and distribute it in? Okay, so if you can't go backwards, if it's multiple choice, you can go forwards. If it's not multiple choice, you wouldn't have to clean it up and you're fine. Okay? This was just a little algebraic challenge for your brain. Don't stress out over that. All right, I want you to try the last one. Now that I've made you work your brains. As a general rule, the place you want to look kind of the first, there's a fraction, is most likely the denominator is where u is going to come from, just by the nature of how all this works. So we would have equals e to the x plus 5. So du equals e to the x dx. So then when I come over here, I've got the integral of this whole thing goes with du, right? So there's going to be 1 over u du. When you take the integral, what do you get? Natural log, absolute value of u. Okay, how we doing? We good? All right. Now on Monday, on Monday, I gave you a stapled pink 2 pieces of paper, this thick packet. Okay, I gave these to you, like, I didn't. Are you sure I didn't? Oh, you're right, I didn't. I thought I did because I pulled those 2 out. Okay.